So like I was just mentioning to everybody, of course we have all of these methods that we've learned about in the past. GCF, difference of perfect squares, sum of and difference of cubes, we learned yesterday. So the sum and difference of cubes formula is going to be on your yesterday's notes. So if you for any reason need that formula, you can reference back to those notes, but we'll be using it today as well. And then of course, we have the other methods. We have polynomials, we factor by using grouping, GCF. Okay, so we're gonna go through and I'm gonna tell you why we picked the method we picked and what method we picked. Some of these will have multiple options of methods that we could choose. So for the very first one, this one here, I see that I have an x to the fourth, I have an x squared, and then I have a constant. So this one here, anytime you have x to the fourth, pretty much you know you're going to get everything to one side of the equation. So step one is to get the 35 to the other side. So you're going to go ahead and subtract that 35 over. My tablet turned off, so give me a minute and then I'll do it. So start by doing that. And there we go. Okay. So this is going to be x to the fourth plus 2x squared minus 35. And that's going to be equal to 0. Now from here, this one has x to the fourth in it. What do we know we can replace x to the fourth with? U squared. And then we can replace x with u. Now we have a situation where we can just factor this as we would factor any other factorable trinomial, right? This trinomial doesn't require me to use AC method or x factor because there is no a term in the beginning. So we can just use normal factoring methods. So what are factors of 35, negative 35 that add up to 2? Positive 7 and negative 5. Now in this case, see how we don't have to divide by anything because we didn't multiply by anything. No AC method, you don't need to divide. So in this case, we can now replace u with what? X squared. Now we're at the stage where this is actually fully factored. There's no more difference of squares or anything like that. So now, here's where we're adding an extra layer into what we learned yesterday. You're now going to set each of these equal to 0. Because remember, our goal now is to solve for x. So I'm setting each of those equal to 0 and solving for x. So over here, I can subtract 7 on both sides. On the other one, I can add 5 on both sides. Then what would I do to solve for x from here? Square root. Very good. So this one's going to give me x equals plus or minus I radical 7. Remember, when you take the square root of a negative, it becomes I. And radical 7, bless you, is not simplifiable, so we leave it as radical 7. And the last and third thing is whenever you take the square root to get an answer to something, you always have that plus or minus because it indicates the two solutions, the one on the negative side and the one on the positive side. Over here, we're going to do the same thing. We're going to square root both sides. That's going to give me x equals plus or minus radical 5, which once again doesn't simplify because they're both prime numbers. So here's how you write your final answer. You can write them out as separate like this. You can say, or you can write them as plus or minus I radical 7 and plus or minus radical 5. Now that we've written our solutions out, we need to analyze these solutions to verify them. So, first and foremost, how many total solutions do we have? 4. So this is very important. If you do not know how to recognize that these represent two solutions, you can always write it separately. You could write negative I radical 7. You got the positive I radical 7. You've got negative radical 5 and positive radical 5. So make sure you remember that this, if you're going to write it like this, that actually represents 4 solutions, the positive and the negative of each. Okay? So how many of those solutions are real numbers? 2. And how many are imaginary? 2. Those total number of zeros add up to the degree of the polynomial? Yes. Remember how you had to do that back when we did graphing? So that's how it applies using the algebra. Okay? So you have to have the same number of zeros as you have degrees of your polynomial. Alright? So does anybody have any questions before we move on? And the answer is these are both acceptable answers. So just make sure you know that they mean the same thing. Okay. Moving on. Yes?
So what's the method called where you
Oh, good question, yes. So this method is called U substitution. So if you didn't write that in, please write U substitution for your method, okay? This is U substitution. All right, letter B. So as of right now, there's really only 3 ways that you encounter a trinomial. I'm sorry, not a trinomial, a cubic polynomial. Cubic is 3rd degree. The first way is that it has a GCF that you can take out an x, okay? The other way is that it's the sum or difference of cubes, where you're going to have 2 terms. And then there's this way, where you have to factor by grouping. Okay, you remember factor by grouping back in the day? You're going to split it down the middle, and then you're going to factor a GCF out on the left and the right. So what can we factor out on the left here? X squared. Good. Which leaves me with x minus 4. Over here, what can we take out? Positive 4. And if you forget how this method works, you group together the ones on the outside, and then if the binomials are in common, this only works if they're in common, that's the other factor. Okay. So if you need a refresher on why that method works, please watch the video. I went in extensive detail about why it works, so if you're curious, it's all there on YouTube. Now we're at the point where we can set each of these equal to 0, right? So set this one equal to 0, and set this one equal to 0. This one is going to become x squared equals negative 4. And then what would we do for the next step of this one? Square root. That gives me x equals plus or minus radical 4, which is equal to 2i. So because 4 is a perfect square, this one simplifies to 2i, right? And then over here, what do we do for this next one? We add 4, so we get x equals 4. So to write our final solution, we have 4, and then we have plus or minus 2i, which you could also write as 4 comma negative 2i and positive 2i. So how many total solutions are there in general? 3. How many of those are imaginary? 2. How many are real? Total number of zeros? You'll never have one imaginary. So here's the reason that you'll never have one imaginary. Only way you can get an imaginary number is when you take square root, right? That's how imaginary numbers come into to be. When you take the square root, you always have a plus and minus, which indicates there's going to be always a pair of imaginary numbers, right? So imaginary numbers always come in that negative and positive pairing. So just something to think about. Okay.
How many zeros did you say?
There's 3 total zeros, 2 of which are imaginary, 1 of which is real. Okay. So method. This was factor by grouping. So go ahead and write factor by grouping for your method. Factor by grouping. So before we move on to the next one, does anyone have any questions about this? Okay. Moving on to letter C. Whenever you have something cubic, whenever you have a variable to a cubic power like this, you always want to get everything to one side of the equation every single time. Okay? So this is going to give me 8 x to the third plus 1 equals 0. So you got to get everything to one side. Typically, there's really only one solving method where you want things on opposite sides. That's square root method. But other than that, you want everything to be on one side of the equation and into standard form, which means the highest degree term first. So then from here, do we have sum or difference of cubes? Sum of cubes, because there's addition between them. Okay, so that's why it's so important you move that 1 over, because it is going to change signs oftentimes. Well, every time if you move something to the other side, it's going to change sign. So to do sum of cubes, you have to identify an A and a B. So the A is going to be the cube root of whatever your first term is, which is 2x. And then the cube root of the second term is 1. So if you're still not 100% sure about cube roots, the calculator will do numerical cube roots for you. As for variables, of course, if it's the third power, you can break it up into 3 different x's. So that would be your cube root. Now you just set up the formula. Like I said, if you don't know this by memory yet, that's okay. It is on the notes. But for now, I'll just tell you what it is. It's going to be a plus b times a squared, which would be 4x squared, plus a times b. Oh, wait, it's minus, sorry. And then it's plus b squared. So when it's a sum of cubes, it's plus minus plus. So from here, you're now going to set each of these in equal to 0. So this is going to be 2x plus 1 equals 0. And this one's going to be 4x squared minus 2x plus 1 equal to 0. Over here, this one's just going to solve to become x equals negative 1/2. And then over here, we have a situation. So I just want to remind everybody in here. Now, normally, when you encounter a trinomial like this, you want to see if it will factor, right? So normally, you would try to use the AC method, where you multiply the 4 and the 1, you see if it factors. But I'll just tell you something to kind of skip forward and save you the time. Anytime you use sum or difference of cubes, the resulting trinomial will never factor, okay? So you wouldn't be wrong to test it out and see if it would factor in any other circumstance. However, you're going to waste your time on tests and quizzes trying to factor these, because they will never factor when they result from this. So if you want to add a note to that, you can. But when you do this method, the resulting trinomial will never factor. So one less thing to waste time on a test. So if something doesn't factor, what are the two other methods we have to get solutions to a trinomial? You're on the right. Completing the square. Yep, completing the square. And what other one? Quadratic formula. Those are our two methods, and I'm going to show you how to determine which method is going to be most useful to you in each circumstance, but I do want to just make sure I point out, those methods always work interchangeably. They work for everything, okay? So, how do we know which one to use and which one's going to be easier? Because remember, you have the sake of time that you want to make sure you're utilizing the most efficient way. So, here's how I determine that. If I were to factor out a 4, because remember, you can't have an a term if you're using completing the square, what's going to happen to this term right here? It's going to become a decimal or a fraction. Completing the square means you have to take half of that and square it. What's going to happen when you're dealing with fractions doing that? It's going to be messy. It's possible, but it's going to be messy. So in this case, something like this, I see a fraction is going to come up. I'm going to try using quadratic formula instead. Okay, so that's how I determine that I'm going to use quadratic formula. So quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. You guys are pretty good with quadratic formula, so I don't feel too worried about that. That's going to be x equals 2 plus or minus negative radical 12 all over 8. So remember, you split this up into the 2. You guys remember this?
Yeah.
And then this right here is going to simplify to become 1/4. And then over here, this right here, this numerator is going to become 2I radical 3. So if you're wondering how I got that, that's because this becomes I times radical 4 times radical 3. Right? I just break down the radical. Radical 4 simplifies to become 2. So if you are still struggling with simplifying radicals, you can either choose to spend the time learning that on your own or get that calculator that does it for you. Okay? At this stage, you can totally do that. So from here, this is going to become 2I radical 3 all over 8. And then can't I reduce this right here? I can reduce this fraction. These are both divisible by 2, which goes over 4, right? So the final answer is going to be that negative 1/2. Feels like we found that ages ago, right? Comma 1/4 plus or minus I radical 3 over 4. And this would also be correct if you put it all over 4, that would be fine too. So let's talk about how many solutions we have. How many solutions does this set represent? 3, because the plus or minus always represents 2, right? So how many of those solutions are real? 1. How many of them is imaginary? 2. Good. So, method we actually use 2 methods, right? We use sum of cubes, and then we use quad formula. Sum of cubes, and then we use quad formula. So does anyone have any questions about that so far? Yes.
The transition from 2i to the square root of 3, can you just like explain that?
What part?
Like, you see 2i and then square root of 3.
That's just the negative square root of 12.
No, but can you explain the steps?
Very briefly, yes, but we don't have a ton of time to do it, so you might have to reference an old video if you don't get it after this. So, this becomes square root of 12 times I. Square root of 12 can be rewritten as square root of 4 times...
No, I know that. It's just how do you get like 1, 4 plus or minus 2, 8, 4?
Because I broke this up right here. I did this over this. So like I divided the 2 by the 8, and I divided the radical negative 12 by the 8. You see what I'm saying?
Yeah.
It's weird, yeah, but it's easier to do it that way than to, you can also factor out a 2 on the top if you wanted to. That would be another choice. Yes?
Do we have to memorize the sum of cubes formula for the quiz?
You do have to know sum or difference of cubes as they come up, and there is no formula sheet for it, yes. I can give you some tips on how to memorize that, though. So sum of cubes is sum, difference, sum, and difference of cubes is minus, plus, plus. Otherwise, they're the same formulas. Okay. So letter D. Everyone ready? All right, for letter D, we have the sum of squares. So if you remember correctly, sum of squares, there's no method to factoring that. So this is one of those scenarios where you actually are going to get the 4 to the other side and square root, okay? So this is going to be x squared equals negative 4. We're going to square root both sides. We get x equals plus or minus 2i. And that's my final answer. Negative 2i and positive 2i, yes.
Why didn't you just do the thing where you write like the parentheses and then a plus or a minus?
That would be if they were the difference of squares.
Oh, okay.
So anytime your resulting answer is imaginary, completely imaginary, that's how we know it's a good indicator that that's not going to factor. So from here, how many real zeros do we have? None. How many imaginary? Does that make sense for the degree of the polynomial? To have 2 total zeros? Yeah, so this quadratic looks like this, if you're wondering. It's with a y-intercept of 4. It never is going to touch the x-axis, which is why the zeros are imaginary. Okay? What?
Sorry, I just figured it out.
Just makes sense now? Just clicks? That's good. So the method is square root method. So the method we used is square root method. All right, everybody ready for letter E?
Yay.
Okay. Letter E, as you can see, we don't have anything squared. So cubes, we know we got to get cubes on the same side. That's the only way we can deal with them. So you got to bring the 64 over. Now, do we have cubes? Remember, there's only a few things we can do with cubes. There's sum of cubes, difference of cubes, factor by grouping, or factor out of GCF. Which is the only one that would work here? Difference of cubes. Yeah, you're close. Not the sum, but the difference. You guys know what sum and difference mean, right?
Yeah.
Difference is subtraction. Sum is addition. So we're not just making up these words. That's what those things represent. So, A is equal to what here? b is equal to 4. The cube root of x cubed and the cube root of
I have a
64.
question about that.
Sure.
So when you have a negative b right there, and
Oh, I
then
see what you're saying, yeah.
how do you get a positive?
So with the formula already deals with the fact that this is subtraction. So when you go to take b, they only mean the number. They don't care about the sign. Does that clear it up? Okay.
So b and a would never be negative.
No.
Or wait, a and b?
Never. Yeah, you're not really going to deal with that. If that ever happens where the a is negative, you need to factor out a negative 1. Alright guys, we're still in the middle of a problem. Just because somebody had to ask a question doesn't mean it's your free time to talk. Okay, so we have difference of cubes. So that's going to be a minus b times a squared plus a times b plus b squared, which is 16. Now you get to this stage and you're ready to set everything equal to 0. And like I said, if you're wondering where this formula comes from, this is straight off yesterday's notes. So if you need to reference that, feel free to reference back to those notes. Now over here, like I said, is there a point in trying to factor this? No, it never factors with this method. So from here we either have the choice of using completing the square or quadratic formula. I opt to use completing the square when I can, and I'm going to show you why. It's a little easier. So in this case, is there any a we have to worry about factoring out? No. When we take half of this, is it going to become a fraction? No. So in that case, it's actually easier to complete the square. Thank you. So this is going to be x. Sorry, I was looking over here. So this is going to be x squared plus 4x equals negative 16. You got to bring that 16 over to the other side. What is half of 4? What's 2 squared? 4. If I add 4 to one side, I have to add 4 to the other side. This is going to factor into 2 binomials. Factors of 4 that add up to 4 are 2 and 2. And if you remember correctly, it's always going to be half of whatever this term is that it factors into. This is going to all be equal to negative 12. So this can be rewritten as x plus 2 squared equals negative 12. And then what's going to be my next step? Square root, square root, square root. This gives me x plus 2 equals. This is going to be plus or minus 2I radical 3. We did that one earlier, so thank you. Okay, so what's my final step to get x by itself? Subtract. Very good. So this gives me x equals negative 2 plus or minus 2I radical 3. So when you go to write your final answer, it's going to be the 4 that you got originally, and then negative 2 plus or minus 2I radical 3. So how many total solutions are there? 3. How many of those are imaginary? 2. How many is real? 1. Does that make sense for the degree of the polynomial? Yes. The methods we used were difference of cubes, and then we used completing the square. So those are the 2 methods that we used. Oftentimes you will have to use a combination of different methods. Okay? Alright, let's go ahead and move on to letter F. Alright, letter F. This is the difference of squares or cubes? Squares. Difference of squares is where you do the plus minus thing. Remember, it's only difference of squares that this works for, not sum. So this is plus and minus. What is the square root of 25x squared? What is the square root of 4? 2, and yep. So then you set these equal to 0. And you get x equals negative 2/5, and you get x equals 2/5. So my final answers are these 2. How many of those solutions are real? Both of them. How many are imaginary?
0.
None of them. So, the degree of the polynomial is 2. We have 2 real solutions. That means that we cross the x-axis 2 separate times. Okay.
What's the method called again?
Oh yeah, this method is called difference of squares. Difference of squares. Alright, you guys ready for another one? Then you're gonna try h on your own. This one's actually really important. So, step 1 is, what do you think we should do to approach this first? Get that 66x cubed over, right? Get the 6x cubed over to the other side. This gives me 3x to the 4th minus 6x cubed plus 12x squared equals 0. So notice I put the 6x cubed in the middle because now it's in descending degree order. Does everybody see that? What I mean by that? Now, if I've taught you anything this whole year, before you try using any of those fancy methods, what should you always try first? Is there a greatest common factor here? What is it? 3 and also x squared. You're going to take out a whole 3x squared, which is going to leave you with this when you do that. Alright, is everybody with me so far on how we got there? Okay, now we're going to set each of these equal to 0. Both of them. This one here, we got to divide by the 3. This gives me x squared equals 0. Take the square root, and you technically get x equals negative 0 and positive 0, but those are actually just really 0, aren't they? Because 0 can't be negative or positive. Can anybody give me a guess on why it matters that there's actually 2 zeros?
Oh, because it's a balance.
Very good, it's a balance. So now that you've learned more about how polynomials work, we know that having 2 zeros makes it different than having it happen just once, right? And in addition to that, that also affects the fact of the number of zeros, right? Because we know there has to be 4 total zeros, so these are each going to count as their own 0 because it occurs twice, okay? Yes. So when you go to write the final answer, I'm going to write 0 twice. You don't have to do that, but I'm trying to do it to show you how it affects the graph and how it ties into what you've learned in the past, okay? So now from here, we're left with something like this. Unfortunately, there are no factors of 4 that add up to negative 2, so we have the option of using completing the square or quadratic formula. I'm going to opt to use completing the square here because there's no a term and the b term is even. So I'm going to move the 4 over. I'm going to take half of negative 2 and square it, which is positive 1. And I'm going to add that to both sides. That means this is going to factor into x minus 1 and x minus 1 equals negative 3. I can rewrite x minus 1 squared. And then I can take the square root of both sides. And like I said, quadratic formula would also work here. That's fine. This gives me plus or minus I radical 3. And you're going to add 1 to both sides. That's going to give you x equals 1 plus or minus I radical 3, which means in total we have 0, 0, and 1 plus or minus I radical 3. Now I do want to mention, I know that you don't need to write the 0 twice. Technically you could write the 0 once, but we do know that the number of zeros that occur affect the way that it looks on the graph, right? So how many zeros do we actually have here? 4. 2 real and 2 imaginary. So the methods we used here is GCF. We first used GCF. Why can't I keep wanting to write GFC? GCF and completing the square. So we used both those methods to be able to get what we ended up with. So what I want everybody to do now is go ahead and try H on your own, and then we will come back to it. and go over it. Okay, I'll put it up on the board.
Wait, what's CLS?
Completing the square. Hi, what's up?
Can you explain why you added like a one?
For which one?
For the last one that we just did, there's 4.
Oh, half of this squared. Half.
Oh, okay.
Yep, and then when you do the 1, you have to do the other side as
Okay,
well.
thank you.
Yep. Yeah.
I forgot my mouse. I'm so sorry.
What did you forget?
My mouse.
You did?
Yeah. It's just so annoying.
It is annoying.
I'm not even gonna lie to you, I kinda like forgot half of those steps that we on solving that. Like I'm saying it